Hi, welcome. In this session, we'll go through addition of matrices. If we have two matrices A and B with I rows and j columns, here we have taken the number of rows as 3 and the number of columns as 3. So we have two 3 by 3 order matrices. Then if we want to add them and let us say the resultant matrix is C, then C will be of the same order as of A and B. It will have the same order because we'll have same number of rows and same number of columns in C. Not only that, each element of C is nothing but sum of the corresponding elements of A and B. What's the meaning of that? The first element of C, C11, is nothing but A11 plus B11. Similarly, the second element will be A12 plus B12, and first row third column element, that is 1 3 element of C, will be corresponding in A what is at 1 3 and B what is at 1 3. If you add them, it will be A13 plus B13. Similarly, you will have A21 plus B21, A22 plus B22, A23 plus B23, and at the end you will have A31 plus B31, A32 plus B32, and A33 plus B33. To just generalized, if A is a matrix of I rows and j columns with an order m by n, and B is also a matrix of I rows and j columns with an order m by n, because I rows and j columns both are same means they both are of the same order, then C, if you want to add them, is nothing but equal to Cij, lower Cij of the same order m by n, where Cij, this is lower Cij is nothing but equal to Aij plus Bij. What's the meaning of that? The meaning of that is, if A is of m by n order matrix, B is also m by n order matrix, then C, if you want to find out A plus B and term it as C, then C is nothing but equal to of same order m by n, and each element of C is nothing but sum of the corresponding elements. If I am interested now, let us say second row second column, C22 is nothing but equal to A22 plus B22. You can see that second row second column C22 is nothing but equal to A22 plus B22. That's how you can add the matrix. Now let's do some simple examples to understand apply the concepts whatever we have just learned. Let's look at this example. We have been given a matrix A and B. You can see that both of them are of order 2 by 2, and also there is a matrix X of the same order 2 by 2 with elements x1, x2, x3, x4. Given to us that A plus B equal to X, then find out the values of x1, x2, x3 and x4. Now we know that whenever you want to add two matrices, what you have to do? You have to add the corresponding elements of the matrix. So X will be nothing but equal to A plus B, that is minus 1 plus 2, first row first column, first row first column. So I'll have 1. Similarly 3 plus 1, 4, 4 plus 3, 7, 2 minus 5, minus 3. But this is nothing but equivalent to whatever is known to us, that is given as that it's equal to x1, x2, x3, x4. Now, if you want to equate these two matrices, then you know that each corresponding element should be equal. Therefore, x1 equal to 1, x2 equal to 4, x3 equal to 7, and x4 equal to minus 3. So we know the values of x1, x2, x3, x4. What we have been given? We have been very simple problem. We have been given two matrices and said that there is another matrix x which is nothing but equal to a plus b. We know how to add the matrices. Just now we have learned we have to add the corresponding elements. So minus 1 plus 2 is 1, 3 plus 1 is 4, 4 plus 3 is 7, 2 minus 5 is minus 3. This is nothing but equal to x1, x2, x3, x4 which is given to us. By equating two matrices, we know that whenever we want to equate the matrices, both are of the same order. That's perfect. And both of them should have corresponding elements equal. That means the variables x1, x2, x3, x4 are respectively 1, 4, 7 and minus 3. Let's do one more example. So we have been given two matrices A, both are of 3 by 3 order. A is having 0, 1, 2, 2, 3, 4, 4, 5, minus 6 in correspondingly in 3 rows. B is having minus 1, 2, 3, 0, 1, 0 and 0, 0, minus 1. We have to find out A plus B and A minus B. We know how to add addition. A plus B is simply you have to add the corresponding elements. So 0 minus 1 is minus 1, 1 plus 2 is 3, 2 plus 3 is 5, 2 plus 0 is 2, 3 plus 1 is 4, 4 plus 0 is 4, 4 plus 0 is 4, 5 plus 0 is 5, and minus 6 plus minus 1, that's nothing but equal to minus 7. That's A plus B. If you want A minus B, now we have seen addition. The subtraction is nothing but you have to multiply. This is nothing but equal to A plus minus of B. That's nothing but you have to add A and minus 1 of B. That means I have to multiply each element with minus 1. Let us do that. Okay. A minus B. That means 0 minus of minus 1. That will be nothing but equal to 0 plus 1. 1. And here 1 minus 2, that is minus 1. 2 minus 3 minus 1. 2 minus 0 is 2. 3 minus 1 equal to 2. 4 minus 0 equal to 4. 4 minus 0, 4. 5 minus 0, 5. Minus 6 minus of minus 1, that's nothing but equal to minus 5. So that's how we can find out A plus B and A minus B. For the first time we are doing A minus B. How to subtract is you have two ways you can do. One, you can subtract each corresponding element, right? 0 minus of minus 1, 1. 3 minus 1, 2. Or you take 3 element minus 6 minus of minus 1, that is minus 6 plus 1 equal to minus 5. Or you can say that subtraction is nothing but addition of negative matrix. So negative means you have to multiply with minus 1 and then you can add it, but both of them will give you the same value. Now just before wrapping up, let us see what are the properties, some properties with respect to the addition of matrices. We know these properties which we are learning from childhood. That's commutative with respect to matrices and addition. A plus B is equal to B plus A. You can cross check that. You can take two matrices arbitrarily, but both of them, make sure that both of them are of same order. That's the only the thing you have to make sure. Commutative, A plus B equal to B plus A. Then you have associative. Associative tells that A plus B plus C is equal to A plus B plus C. Then we have Additive identity. What's the meaning of additive identity? Additive identity means what I can add to this matrix so that in return I will get again matrix. That's nothing but equal to 0, null matrix. How null matrix will be there? Null matrix will be of the same order as that of A, but it will have all zeros as elements. That's a null matrix for you. Then what is the another one? Additive inverse. Additive inverse means the matrix which if I add to A will make it as 0. A plus B is equal to B plus A equal to 0. Then B, which is equal to minus A, is called as additive inverse. Additive inverse. So these are some properties. And also see, you can do scalar multiplication also. That means K of multiply each element of matrix A is nothing but equal to a matrix of Ka. What exactly is the meaning of that? The meaning of that is that if you have, let us say A is equal to Aij of m cross n. Okay, right? Then K, a variable, multiply with all the elements is nothing but equal to multiply each element of A with that where K is nothing but equal to, if you are saying 2A, 2 into A is nothing but equal to multiplying each element of A with 2. That's the meaning of scalar multiplication. You just multiply with that number each element of the matrix. In the next video, we will see multiplication of matrices. Thanks for visiting. Bye for now.